Hello, everybody. This video is going to be about a specific type of question that pops up on the AP every year. It is about how to find the derivative of a function's inverse at a specific point. So before we jump into the calculus of it, I just want to review a couple things about inverse functions in general that you hopefully covered last year in pre-cal. So just a couple reminders. Functions that are inverses of each other are reflections of each other over the line y equals x. So the line y equals x is the 45-degree line. The graphs of inverses, you just flip them over that line, and that's the graph of the inverse. That means that if the point a comma b, so if we put in numbers for a and b, let's say it was 5 comma 7. If the point 5 comma 7 is on f of x, then the point 7 comma 5 has to be on f inverse, on the inverse function. Because that's what a reflection over the line y equals x means you just swap the x and the y coordinates. So if a point 5 comma 7 is on f of x, then 7 comma 5 is on f inverse of x. Okay. Furthermore, so if we think about those 2 points, the original point a comma b, and let's call it its reflection point, b comma a. At a point in its reflection point, the slope of the function is going to be reciprocals of each other. So we have a specific example in this graph here. Here the point we're talking about, so the two functions we have here are x squared and square root of x, which are inverses of each other. And you can see the first property that I was just talking about is true. The point 2 comma 4 is on the graph of x squared, and then the point 4 comma 2 is on the graph of square root of x. So here's the original point, here's its reflection point. If you go through the math, you can see that if f of x is x squared, f prime of x is 2x. When x equals 2, the slope of x squared is equal to 4. So that means that if what I've said over here about the properties of inverse is true, then the slope of square root of x at 4 comma 2, the reflection point, that should be 1/4. And we can figure that out. So if g of x is square root of x, that means g prime is 1/2 x to the negative 1/2. So g prime of 4 is 1/2 times 1 over the square root of 4, which turns out is 1/4. So the slopes are reciprocals. Okay, so we're going to use these two facts that the coordinates of a point correspond to a reflection point on the inverse, just with the coordinates swapped, and that the slopes at those 2 points are reciprocals of each other. Okay. All right. So this allows us to find the derivative of a function's inverse at a specific point without actually having to invert the function. So inverting functions is not always even possible, and when it is possible, it can sometimes be like a huge pain to do it. So this is kind of nice because it allows us to be able to figure out the value of the derivative of an inverse function without actually having to go through the steps of inverting the function. So like, here's an example. We're given f of x is x cubed minus 2x squared plus 8x minus 3. This function isn't even invertible, but we're just going to roll with this. And the problem is asking us to find f inverse prime of 13. So we want to find the rate of change of the inverse of f at when the input value is 13. Okay, so this piece of information that we're getting here in this part of the problem is that the point 13 comma question mark is on the inverse function. Right, so we know that the input value is 13. Because we don't know the equation for f inverse, we do not know the vertical coordinate at that point. We just know that the input coordinate is 13. Well, this tells us that the point, so if the point 13 comma question mark is on F inverse, that means that the point question mark comma 13 must be on F of X. And we do have an equation for F of X. So if we want to figure out what the input value needs to be, so what question mark needs to be in order to get an output of 13, we can do that because we have an equation. So I want to solve for what input I need to put into F in order to get 13 out. So to do that, I'm just going to set F of X equal to 13 and solve. Sorry, that should be a 2x squared. Okay, and then I'm going to subtract the 13 over. Okay, when I see 4 terms, I immediately want to think factoring by grouping. There's an x squared in common in the first 2 terms, and there is an 8 in common in the second 2 terms. And lo and behold, now both terms have an x minus 2 in common. Okay, this factor, x squared plus 8, can never equal 0. So there's no solutions from this parentheses, but we have a solution here. Sorry, x equals 2. So we know that when we put in 2 for x, we get 13 out, so that means the question mark has to be equal to 2. So we know the point 2 comma 13 is on F of X. Okay. Okay, so that's useful information. We're going to use it to finish the problem on the next slide. Okay, so now we know that the point 2 comma 13 is on F of X. Remember, we are trying to find the derivative of F inverse at the point 13 comma 2. So the point 2 comma 13 is on F of X, the point 13 comma 2 is on F inverse of X. And this is the point where we are trying to find the slope of the inverse of F. Well, I don't have an equation for F inverse, but I do know that at this point, 2 comma 13, the slope of F of X is going to be the reciprocal of the slope of F inverse of X at 13 comma 2. So because these 2 points are reflection points of each other, we've swapped the X and Y coordinate. At these points, the slopes of their 2 functions, F and F inverse, will be reciprocals. That's what we saw on the first slide with the graph of X squared and the square root of X, where the slopes were 4 and 1/4. So what we're going to do is we're going to find the slope of F at the point 2 comma 13, and then we're just going to take the reciprocal, and that will tell us the slope of F inverse at the point 13 comma 2. Okay, so let's take the derivative of F. 3x squared minus 4x plus 8. And we are trying to find the slope of F when x equals 2. So this is going to be 12 minus 8 plus 8, so you get 12. So if F prime at 2 is equal to 12, that means that the slope of F inverse at the point when x equals 13, F inverse prime of 13 is 1 over F prime of 2, so that's 1/12, and that is the final answer. So you just need to work out the coordinates of the 2 reflection points, and then take the derivative of F, and then take its reciprocal. Okay, we're going to see another example. Okay, here's an example for you to try. I'm gonna pause it and put up the work, and then you can check to see if you got it right. But you go ahead and try it and put it in play pause it. Okay, so here's the solution. Started over here. I found what input value on f of x will lead to an output value of 192. I found that the answer is 3. So the point 3 comma 192 is on f of x, and the point 192 comma 3 is that reflection point on f inverse. So then I wanted to find f inverse of 3. Took the derivative. When you take the derivative of an exponential function, this 3 just hangs out in front because it was a coefficient. It's the natural log of the base times the original function times the derivative of the exponent. In this case, that was just 1. Then when I plugged in 3, you get 4 cubed here. That's 64. 3 times 64 is 192. So you get 192 natural log of 4. You can just leave it like that. You don't need to put in a calculator. And then the last step, to find the derivative of f inverse at 192, you take the reciprocal of that. So the final answer is 1 over 192 natural log of 4. Okay. There's another format in which you will see these problems. Sometimes you'll be given a table of values. That is actually even easier. There's way fewer computations. So instead of just giving us equations, we have a table of value for f and f prime. And the question is asking us to find f prime inverse or f inverse prime of 28. So we're going to go through the same process as we just did, but we will just use the table. So the inputs for f inverse are the output values for f of x. So here I see 28. That means the input value we're looking at is 5. So I want to find the derivative of f when x equals 5. Luckily, that's given to us right here. So f prime of 5 is equal to 10. To get the derivative of f inverse, at this point, I just need to take the reciprocal. So f prime inverse, or f inverse prime, of 28 is going to be 1/10. So you just look for the value, the output value. So the input into the inverse is going to be the output of the original function. So you look in the output, the f of x column, you see what f prime is at that point, and then you take the reciprocal. Okay. And that's it for this one. So there are some practice problems in the book that I'll post up on Haiku. But that's about it for this. All right, thanks. Bye.